Another Monday evening of Fresh Natural Live. And as we promised, we'd be sharing some insights with you on how to boost your immune system. And so I hope your Monday is gone here in Houston, Texas. So I suspect other parts of the country, certainly in the Northeast and maybe some parts of the Northwest, are getting even cooler. And, the holiday seasons are around the corner. And with the holiday season, it gets darker and, we tend to huddle indoors more and do all the types of things that will decrease our vitamin D levels and also suppress our immune system. So what we're going to talk about tonight is ways of creating a natural shield, ways of enhancing your immune system and getting prepared for the winter months. As you know, flu season kicks in. Of course, the COVID virus is around. And there are other types of viral infections or bacterial infections that you can be predisposed to. These things trigger inflammation and can get you sick in other ways. And so it's around the holiday time, the morbidity, mortality, of our population increases. So what we want to do is give you some insights that you can share with friends and loved ones, and of course apply yourself. That's going to help you get through this season and enjoy the season and not be sick during the season or heaven forbid suffer any tragic health conditions. So sit back and stay tuned. We have a great show lined up for you tonight. Okay, I'm back, and hello to the group: Catherine Welch, Jane Doe, Cindy Gitson. Hello, how are you doing? Hello, Danielle Harding and My Rich One, Joy 31608. How are you doing this evening? Jackie Leftwich, how are you today? Jane Doe and Dellum and everybody else, how are you doing today? I'm going to invite my friend and colleague, Dr. Ford Atkins, on. Good evening, sir. How are you doing today? How's your Monday going?
Doing fine today. How are you doing?
Just fine, just fine. So it's getting a little cool here. I don't know what part of the world you're at right now. So you're in Costa Rica or what?
Yeah, not quite cool here yet. It was I was sweating all day today, so
okay.
I apologize.
No, that's okay. That's okay. Not a problem. But we've been doing these infrared saunas at our facility. And, I go to the facility to get in the sauna, but I decided to break down and get one for my house. And I plan to get one for the outdoors, but the waiting period is like till March. Mm-hmm. So I went ahead and got one. I'm putting it indoors. So it's going to be delivered tomorrow and either installed tomorrow or Wednesday. So I'll be able to sweat on the indoors. But I've been trying to get to use the sauna more. It's the few times I've used it's helped with my workouts. And so yes. Infrared sauna is one of those things that also helps enhance immune system and has some, I'm told has some antiviral properties or the like. So anyway, maybe we'll touch on some of that today. Yes. But you have a great presentation. I understand the natural antiviral shield is tell us what we're going to be enlightened with this evening.
Well, we want to cover, as you know, according to CDC, World Health Organization, from October till basically March is considered the flu season, seasonal flu. We've been dealing with flus for the last, 20 months or so, but now we have a influenza, let me put it that way, a virus, but now it's the seasonal virus. And I'm going to just enlighten the audience on the differences, the likenesses, and how we can protect ourselves. Again, I guess the first half of the show, I really want to talk about what the virus is all about so people get an understanding, because there is, information that we hear, but people don't digest it necessarily. So hopefully this information helps you digest it. This is information that's it's based on facts, based on what the CDC and World Health Organization has determined what everything is, and we need to know because people have a lot of misinformation.
Yeah, there's a lot of misinformation going around, and I think it's important, as you said, to point out the facts. So for all of you, I'll say up front, there's going to be a lot of important information. If you hadn't subscribed to this channel, I suspect many of you have. Please do so. Hit the like button so this message will go around. Even hit the love button, and of course, please share this information. This is going to be very important information that Dr. Floyd Atkins is going to share with us tonight. So get the message out, share it right now so people can join us live. But if not, they can also see the recording. So let's get started. So this natural antiviral shield. So I guess you're going to start off with what the definition of a viral infection is, or flu season, influenza, sort of help us out in terms of understanding what all of that means.
Absolutely. Sounds like you've seen the presentation already, but this is the first time. But yeah, that's important to deal with because people have to really understand what a virus is. When I started to just put together this research, I realized that, people have heard of influenza virus. You have an idea what a virus does, but actually what a virus is and how it works. And so I really try to simplify it because, virology or the study of virus can be very complicated because it's a lot involved. There's a lot of moving parts, but I really try to simplify it so people can understand what we're dealing with in this day and age right now. So if it's okay, I'm going to get started right now. Is it okay?
Yep, that's perfect.
Okay, let me see. Now, do I need to share anything to?
It's you should see it on the screen. It's I see it. We see it on the main screen, so you can just actually run it from your PowerPoint.
Okay.
If you just go to your view and run it on your PowerPoint, it should it'll advance on our screen. Because what we see your lead slide, creating an antiviral shield.
Okay. Do you see my cursor at all?
Let's see. I don't see your cursor. I see your screen very well, though. I'm going to invite Dr. Celeste Palmer in. Hello, Dr. Palmer. How are you doing?
I'm well. Hi, Dr. Atkins.
Hello. How are you doing today?
Good.
He's trying to find his slides. We see them very well here.
Okay. You see?
I see your cursor now.
Oh, okay. Good. Well, we're in the right place. Okay. We are going to really share some information about creating an antiviral shield. And the reason I refer to it as an antiviral shield is because viruses are parasites. They are part of the environment. They're part of the world we live in. And it's getting rid of viruses like getting rid of bacteria, mold, and fungus. You can't get rid of it, but you can protect yourself from it. And actually, you can prevent it or avoid them or create an environment where they don't have the tremendous impact on our lives. And that's what we're going to really discuss today. But let me start off by discussing exactly what a virus is. And this is information that came from the medical microbiology resource, also the Center for Disease Control put out this information too. But the definition, viruses are microscopic parasites that are generally smaller than bacteria. And when we think of viruses, we don't necessarily think of a parasite, but it is a parasite because it needs us. It needs a human host or an animal host, an organism to be able to live itself. It's only partially alive. They contain nucleic acids. They contain DNA or RNA. Remember, DNA or RNA, never both. Which are the keys to all living elements. A virus is a parasite that requires replication. And what that really means is it has to make copies of itself to grow and multiply and spread. It has to have a way to replicate. Well, it doesn't have the ability to do that on its own. So that's where the human or live organisms come into play. The primary role of a virus or virion is to deliver its DNA or its RNA genome, that's the DNA material inside the virus, into the host cell, so that host cell can translate, can transcribe, can be transcribed by the host. So in other words, it's basically non-living. It's just like a key and a lock. It's the key, but it needs a lock, and the lock becomes a human host who's able to take the DNA, and then it actually it sends a message to the DNA in our bodies, or to the cells in our bodies, to make another copy of the virus. Viruses can attain access to the host through respiratory passages, through open wounds, and sometimes insect bites. We know things like dengue fever, yellow fever, malaria can all be transmitted that way, transferred that way. But the virus has to get inside the host cell to be able to replicate itself. They spread both inside the host cell and by the host cell itself. And that shows you how I guess intelligent or smart that this particular particle works. It's number one, when it goes inside your body, it recruits your own DNA cells to replicate itself, to make more viruses. And then number two, the symptoms that you get, the coughing, the sneezing, the runny nose. And an example of that, when you sneeze, you emit approximately 20,000 droplets of water containing rhinovirus or coronavirus particles. And this is just information that's provided by the molecular biologist Cells Research book. But the virus itself, by having the symptoms, actually helps spread it to other people through coughing, through sneezing, and through runny nose. You have a runny nose, you touch your nose, you wipe your nose with your hand or a towel. As soon as you get the mucus on your hands, you spread it to everything you touch at that point. So that's why washing hands is so important. That's why when coughing and sneezing, water droplets are so important to preventing viral spread. Touching and breathing these droplets, it's all it takes to spread the cold or virus to someone else. So it has its own built-in mechanisms for not only replicating itself, but also dispersing itself through an environment. What is an influenza virus? Influenza, as we call it, the flu, is a contagious viral infection that attacks your respiratory system, your nose, your throat, and lungs. It can cause mild to severe illness and sometimes can lead to death. And there are basically three types of influenza: type A, B, and C. And those are further broken down into other subtypes and subcategories. But with human seasonal flu viruses, what we're going to discuss, what we're discussing today, there are really two types of influenzas that cause the seasonal flus that we see now, and that's type A and type B. And probably right now, type A is the most common we've seen in the last few years. But when you look at type A, which is at the top here, there are subtypes. There's H1N1, H3N3, and there are probably 18 or 19 other subtypes in that category. And then they have the subtypes are broken up into what we call clades. And clades are subtypes of the subtype, and then you have subclades. And these are all, in layman's term, when you hear it on the news, is referred to as a new strain, a new strain of the virus. And so when you have a different strain, they fall into one of these clades or these subclads of the virus, or even a subtype, more likely subclass. And it's where you see the strains. And those are basically just mutations of the original virus. Say, for instance, if the virus puts its DNA into you to make new viruses, where every person, every ethnic group, every the genetic makeup of every individual can actually produce a different micro strain of a virus, because it takes your DNA and its DNA and comes out and makes and repeats itself. So what happens is you can get a strain throughout a population.
So let me ask you real quick. Sure. I'm gonna make a quick comment and then a question.
Sure.
And just to reiterate to the audience, you talk about the primary role of the virus to deliver its DNA and RNA to replicate itself, and I want people to put that in the context of all species, and species in the animal kingdom, they are designed to replicate themselves. I mean, our bodies are designed to replicate and perpetuate your existence. And so we have
Yes.
offspring, and so viruses are no different. So at the primary level, it has this primary need to replicate itself. And so the most efficient viruses are going to be the ones that, do things to replicate itself. So you made an important point. It needs the host to replicate. So
Yeah.
just think about it. The most lethal viruses that kill their host and kill the host effectively and fast and effectively are not going to be the ones that are going to be as contagious because they can't replicate themselves very well. The ones that are less contagious, less lethal, are going to be more contagious, and they will replicate themselves. So it's really hard to get that combination of virus that's super lethal and super contagious, because if you kill your host, at the first sneeze, then the host doesn't sneeze but once, if at all, and
Yes.
you don't spread. So that's just one little observation I thought of listening to your comment. But the question I have is that these influenza are these descendants of the 1918 flu, or some of these descendants of the 1918 flu?
Well, some of these are, and I think they were more along the, let me go back to that slide. They're more along the influenza B, because the
Okay.
influenza A, what we see with the subtype H1N1, was really a new virus that we saw beginning in 2009, 2010. Prior to that, I think 1968, there was the Russian flu, and it was 1948, it was flu. About every 30 to 40 years, we see a different strand. But right now, in the last 10 years, it was a subtype of the H1N1, but now what we're seeing is a SARS, which is a little bit different, but it's a new introduction. And that's something we can discuss a little bit in the second half, because I think it has a big impact on what's going on now.
Can I throw in something, Dr. Atkins?
Sure, absolutely.
So, Dr. Montgomery, based on what you said, we're talking about flu. Since flu has been around for many years and it's very easily caught, it should be, by definition, less lethal at this point.
Mm-hmm.
Yes.
Okay.
Yeah, we can definitely all agree on that.
Unless the host is very weak.
Yeah, and it's that's what they want to I guess describe the virus as being more viral or virulent. But from what I see here and what we've seen in the past, and you start looking at numbers, you see I think it's the host is the one that's changing. It's not necessarily the virus is getting stronger. What I want to say about this slide here is what about viral infections, and they're classified by time and by prevalence in the population, by length of time and by prevalence. And what I mean by this, this is where I think some misnomers have come in, even when it comes to the media, when they describe what's going on. We describe the seasonal flu, and the media comes out where the seasonal flu is not the COVID, it's not a pandemic, but this is definition information from the Center for Disease Control. Seasonal flu is a flu virus. It varies in occurrence. That means it mostly it can vary from a small group, from a community, to a town, to a small area, to a region, or just within a small population. And it happens according to seasons, mainly March through October in the Northern Hemisphere and April through September in the Southern Hemisphere. And what was interesting to me that I didn't realize in the tropics and subtropical countries that it really exists. Seasonal flu exists all year round. So you can't really characterize it as seasonal flu. It's just a virus, a parasite that happens to be around all the time. An epidemic is described as an disproportionate number of individuals, affects a disproportionate number of individuals within a population, community, or region. So an epidemic can be something that starts off as a seasonal or localized event, and if it spreads to a large enough population or community or region all at the same time, we call it an epidemic. And again, it's a progression. It's still the same thing that starts off as an outbreak, which is a seasonal flu, and an epidemic. It goes on. Now, one thing about epidemics that I want people to understand too, that it's not necessarily contagious. You can have an epidemic. Viral epidemic can be one thing, but it doesn't have to be contagious. You can say, for instance, obesity. In America, obesity and diabetes are epidemic, but they are not necessarily contagious, unless everybody's eating at the same buffet bar or something. But understanding that just because you have epidemic doesn't mean it's something that can spread that way. But an epidemic has affect a disproportionately large number of people, usually pretty rapidly. And then pandemic occurs over wide geographical areas, usually multiple countries or multiple continents, and typically affects a significant amount of population. When the CDC and the World Health Organization determine what's a pandemic, it depends on if it's in multiple countries and if it's affecting a large population. So it goes back to so go back to prevalence in the population. How long has it been there, and how many people, and how far wide it's spread? So what we see is that, and this is according to definition provided by health organizations, that an outbreak is a first step, an epidemic is a second step, and a pandemic is a broader step, or the most widely contagious situation. So when we talk about, so when I hear the news media speak of COVID, like it's something different. COVID, if it only broke out in New York or New Jersey, we would still consider that an outbreak or seasonal flu. If it went across half the nation, we could call it an epidemic. But if it goes in multiple countries, then we call it a pandemic because it's affecting so many people. So it goes back to a virus is a virus is a virus. So it goes back to how do we handle it.
And I just flashed up Yolanda Williams' question because you were just answering that. So that's why I put it up there while you were giving that answer. So,
okay.
So you were addressing that in that slide and that point. But anyway, go ahead. Sorry.
And this is another example here that we want to talk about the difference between pandemic to seasonal flu. In 2009 to 2010, the first flu pandemic in more than 40 years was a swine flu. I don't know if most people remember the swine flu epidemic, which was the H1N1, which was a type A influenza. And it was caused by a new flu virus. When H1N1 came out, that was something we hadn't really heard of before, known as H1N1, an influenza virus that was a combination of swine, avian, and human genome or human genes that mixed together in pigs and spread to humans. Now that's a tall glass of water there, because I was looking at the research to say, so we start off with a gene from a swine, a genetic material from swine and a bird and a human being, and somehow the pigs were able to take the virus and they replicate the virus in the pig, and then the pigs again, breathed in the air or spread it on the humans, and that's how we got it. So that to give you an idea of how it spreads or how this particular virus spread it. Now, today, H1N1, this is 10 years later, 11 years later, H1N1 is now considered a normal seasonal flu and is included in the flu vaccines that you get. So if anyone determines they're going to get the flu vaccine now, the seasonal flu for this winter, H1N1 is one of the viral strains that's in that vaccine, along with others, because they put multiple viral strains in each vaccine because they don't know exactly which strain that was going to be most predominant. But what they do is they predict through some method what they think is going to be the predominant strains for a particular part of the world and for a particular time of the year. And
I'm sorry. So how the swine? So do they transmit the virus to humans by sneezing on the humans, kissing the humans, or being eaten by the humans?
And that was exactly my question. That was exactly my question. And I researched. I find very little information on how. Number one, I'm trying to figure out how the swine, the bird, and the human got together. Did we eat pork chops and chicken at the dinner table, and we got that virus, and then we have to transfer it to a pig. We kiss the pig, and then we spread it to humans again. Not making light of it, but it's these kind of things doesn't appear that it can happen so easily in nature. It doesn't seem natural to me because it takes a lot, and not that it can happen, but it can, because viruses are everywhere and they spread easily. But that combination, as they determine.
Well, not meaning to throw another animal in this, but it's something a little fishy about that, don't you think?
Well, it's a little smelly. I think it's a little smelly. So and I want to share with the audience. I have been researching. I didn't get a chance to enough time to finish it up for this episode, but I am looking into that question, that very question, because. What normal research dictates is that these things you have to actually experiment or test these in a laboratory, put these things together in a laboratory to see how they work. So it would be much easier to take genetic material from these three or from viral material from these three animals or these three sources and put them together to come up with it, rather than for them to spread by some means between animal to animal to human to animal back to human. It is fishy. Okay, one thing I want to cover also, and this is just give people an idea about the seasonal flu and how another reason that we should work on protecting ourselves rather than depending on just not doing anything. And this is a list of seasonal flus and the estimate of deaths in the United States alone from the seasonal flu. So we see in 2010 to 2011, initially, there were estimated 290,000 hospitalizations, and the estimated deaths were 37,000 people died that year of the seasonal flu. And what is peculiar in all my research, I keep coming up with data. What is peculiar is that they have what they call the deaths 95% UI, which is uncertainty interval. They're not sure exactly how many people died, but they estimated 37,000 people died. But when they look at the uncertainty, it could have been 32,000 to 51,000. And so
those are broad ranges there, for sure.
Yeah, they're very broad ranges.
3,000 to 95,500.
Yeah. In 2014, you got 33,000 to 50,000. And then, but the even more peculiar thing, when you look at the numbers and you look at the estimates are always on the low end of the range. So if it says that 11 to 23,000 died in 2012, they only had 12,000 deaths. So, but based on a bell-shaped curve, if you had 11 to 23, it should be around 18. You should take the middle point of the curve rather than taking, the ends. So it makes you be concerned about the numbers, or how they come up with the numbers, how they decide. Like in 2017, 2018, and there was another epidemic then, but they said it between 3,000 and 95,000 people died, and they estimated maybe 52,000. And that's kind of a mid-range number there, which seems more likely. And again, the CDC have continually over time, usually 2 to 3 years after they report a number, they're adjusting the figure because they either get more information, or I don't know how they come up with the adjustments on the number when you can't document those things. Technically you can document it to a degree, but they can't document every death, but that's what they attempt to do. The two in the bottom of this slide says the 2019-2020 season has a preliminary estimate. They don't have any final numbers on that so far. And then being able to determine, like in 2010, 2011, it was the end of a pandemic, how many of those deaths were due to what we call the pandemic portion of the season, or even during this COVID season, how many are seasonal deaths that we have last October to February to March, and how many of them were actually seasonal flu.
And then one thing I want to point out to the audience, as you go through this data, and it's quite interesting, and I think you do an excellent job of pointing out kind of the struggles in tracking this data. And I think, there are a lot of components that contribute to this difficulty. And one I will clearly say is, frequently the people who are likely to be ill and go to the hospital from influenza or any other viral infection have multiple, as we say, comorbidities, heart disease, etc. And we know based on disease mechanism that you get an infection that can trigger a stroke, it can trigger a heart attack, it can trigger, inflammatory lung disease, secondary pneumonia. So these people are coming in, they're very ill. And so influenza may be part of what they have, and it may be triggering something else that they die from. And you say, okay, they have influenza plus this, that, and the other. And so it's really hard to pinpoint one thing, because people don't just simply die. Okay, they raise a hand. Okay, I've got influenza, so I'm going to die from this. Or I've got, pneumonia, I'm going to die for that. Frequently people die. There are multiple factors it's almost like you got beat up by 5 people. And there's Bob, Amy, Joe, Ted, etc. And you say, well, who beat you up? It's, well, there were 5 folks who jumped me, and everybody got a punch in. So I don't know who knocked me out, but everybody got a punch in. And so you're sort of dealing with that when people who are sick go into the hospital. And I thought I'd just kind of throw that out, because it is hard to figure it out. Plus, you don't have good data and so on and so forth.
And
Yes.
I would be interested in, I know you just said about 2020 and 2021, because I know they said a lot of people weren't going to be tested and it may have been covered by the current pandemic, but I did test people in clinic, and the flu A and B was coming back negative. So it's just interesting to know what, because we had record lows last year. I mean, we know that, but just how low did it go?
Yes. And I look at this data, and and I'm kind of looking at it with a fine tooth comb. When I look at 2010 to 2014, I see that the estimates are on the bottom end of the uncertain of the range. So the range is 32. The estimate is 37. When you look at 2016, 17, 18, it's the numbers are 16, 17, 18. The numbers are mid range. So the idea, if I was doing research, I want to keep the numbers low and estimate. And I'm saying it because it's what the information I have. It's not because I say they did it, but they have low numbers on the ranges to advocate that maybe the flu vaccine, the seasonal flu vaccine is working or not working. But it seems like in 16, 17, 18, they were mid-range, which they could be working, but that seems more reasonable. And then in 19 and 20, it's getting very low again. If it's at 18,000 to 80,000 possibilities of the range is, but 20,000 people they estimate. So how do you have a range that big and only estimate 20 out of that? So it's just if an epidemiologist had to look at this, they would have a lot of questions of what I'm saying, because I don't know how to come up with it. And I'm just sharing what, as a researcher and as a scientist myself, what I see and what I would expect other researchers to see also. Treatment for H1N1 flu. This is just a general, we're going to talk about seasonal flu and how that got started. But drink water. This was the recommended dosage back in 2010 if you did contract H1N1. Over-the-counter symptoms from over-the-counter medication for symptoms, antiviral prescriptions, run your immunity, drink plenty of water, get rest. Okay, we're going to talk specifically. I'm going to cover a couple things about the seasonal flu, and then we're going to, in the second half, we can talk about the remedies. Seasonal flu is a flu most often caused by type A, type B. The symptoms we see, which most people are familiar with: dry cough, chills, fevers, runny nose, headache, muscle aches. Those are the most common signs we see. So no matter what the virus is called, what name or letters or alphabets or Greek alphabets they put on it, the symptoms are pretty much the same. You might have a few more respiratory symptoms, with some more than others. Most people recover from fever and other symptoms within a week without requiring medical attention. Influenza can cause severe illness or death in high-risk groups, which what we've seen and we understand. So if we want to take a break now, we can have a discussion.
I think this would be a great time to take a break. And one thing I want to mention on that last slide was an excellent slide, is that these symptoms are your immune system responding to the infection. And to some extent, it's good. It's really a innate immune system. Now, what happens is that if the innate immune system, if your immune system is in disarray, and I know you're going to get that in the next slide, then it's going to overreact. And that's what makes you sicker, is that an immune system that's in disarray. And so some of the things we'll talk to you about is how to keep your immune system in control and order. So it's not a matter of having a high or strong immune system. You have to have a strong immune system that's orderly and in control, not in disarray, not drunk. And so an immune system in disarray is going to give you more and more of these symptoms, going to make you sicker. So I suspect we're going to address that on the other side of the show. Let's take a quick break now.